Greetings, everybody. Let's look at this question where we are asked to find the z-score for various data values. Leading up to that, we're given that there's a selection of exam scores. They're normally distributed. There's a mean of 20.9 and a standard deviation of 5.4. And from there, we calculate some z-scores. So before we do that, so what's a z-score? We can calculate it like this. You take the data value you're given, you subtract the mean, which you're also given, and you divide that by the standard deviation. Okay? And what that tells us is how many standard deviations the data value is away from the mean. Okay? Most of the data will be near the mean, and it's more and more unlikely that there's data further and further away from the mean. Okay, so the z-score tells us how far away the data value is from the mean. Okay, in terms of how many standard deviations. And the reason we measure it that way is that data values more than 2 standard deviations away from the mean are unusual. Like I said, most of the data is in the middle, close to the mean. Okay, and if you get more than 2 standard deviations away from the mean, then it would be unusual for that to happen. Okay, so let's use that to calculate the z-score for this first data value. I've got these 4 data values that are scores on a standardized test. The first one's 14. Okay, so let's look at that. So I was given that the mean's 20.9, the standard deviation is 5.4. So according to that formula, the data value for the number 14 has a z-score of 14 minus 20.9 over 5.4. That's the data value minus the mean over the standard deviation. So I'll get a negative number, negative 1.27777. Okay, so there's my z-score. Now this number takes some rounding, and I noticed that the question says round to 2 decimal places. Okay, so if I get negative 1.277, so if rounding that to 2 decimal places, I have to round the second digit there after the decimal up to an 8. So 1.28 to 2 decimal places. Whoops. Okay, so negative 1.28. There's my z-score for that first data value. From there, I'm asked to calculate the z-scores for the other 3 data values, 21, 9, and 36. So I'll pause the video to work that out. I'll show you what I get. Okay, so now I've calculated the z-scores for the data values 21, 9, and 36. Okay, now a few comments about that. First of all, is the z-score for 36, when I used my calculator, it was 2.796. Okay, when I round that to 2 decimal places, because the 6 is 1 digit to the right of the 9, I would have to bump the 9 up. All right. And that would bump the 7 up, so I get 2.80, rounding that to 2 decimal places. Another thing is, if the z-score is negative, that means the data value is less than the mean. Okay, and if the z-score was positive, that means it's to the right of the mean. Okay, so that's why some of these are negative and some of these are positive. Tells you positionally if they're more than the mean or less than the mean. Now, next, so I entered all those values, and next part is which values, if any, are unusual. Okay, well, so I did tell you that unusual values are more than 2 standard deviations away from the mean, and that means that if the z-score is bigger than 2 or less than negative 2, it would be more than 2 standard deviations from the mean, and the data value would be unusual. So the data values that are unusual among 14, 21, 9, and 36 are 9 and 36. Okay, all right, so I'm going to have to select A. There are unusual values, and it's 9 and 36, and the way that I enter that in is to separate those answers by a comma, just like it says there. So 9 comma 36, those are the unusual ones. Okay, all right, there we go, and it's correct. Now, it doesn't matter as far as being unusual whether the z-score is positive or negative. All that matters is if it's more than 2 or less than negative 2.